Video, I'm going to show you how to implement some command security workflow on Gloo Gateway using the Kubernetes Gateway API. So I have already deployed Keycloak that I'm going to use to demonstrate how we can apply OIDC workflow, how we can authenticate with JWT tokens, and so on. So let's get started. So the first thing I'm going to do is creating this Gloo Gateway object that is called hot_config, and I say I want to apply this OIDC workflow. I want to secure with all the Keycloak information that you generally need when you implement this type of workflow. I also configure like a logout path if I want to log out. And here I configure the session information. Instead of storing the ID token that I'm going to get after the OIDC workflow is executed, instead of storing that as a cookie in the browser, we are going to store this in Redis and having this session cookie created instead, so that after the user is authenticated for the next request, the gateway is going to receive a request with the session cookie, and the X.dot server will exchange that, getting the real ID token from Redis basically. We also configure it in a way that we want the JWT token to be available under this header called JWT, and we also want to extract one of the claim, the one called email, to create a new header X email. So I just create this object, then I create a root option which reference this hot config. You will see that we are going to build upon that and create some additional entries here to apply transformation, rate limiting, and so on. So I execute this, and what I'm going to do then is creating a standard Kubernetes Gateway API HTTP route where I match for any request. You see, and I have done a video about delegation before, this is an HTTP bin that we consider as being a chilled HTTP route, sorry. And that's why you don't see any parent ref and host name. And here I just use this filter extension ref to tell I want to apply this route option to this route here that match any request. So if I go to my HTTP bin application here, you see that now I am redirected directly to Keycloak, and I can authenticate as user 1. And after I authenticate, I can see that I see the JWT here added in this header like I was asking, and you can see this X email added, extracted from the JWT. So that allows the application that receives this call to know who is the user without having to decode the JWT header. But you will see that it's also something we can leverage for building a more complex workflow. So right now I authenticate users, and it doesn't matter all the users have access to this application. But what I can do is that I can leverage Open Policy Agent policy to add an authorization rule. So for people who are not familiar with Open Policy Agent, it has a language called Rego that can be used to authorize requests that may be requests when someone does any change in the infrastructure, but can also be used by applications like we are going to do here. Generally, you deploy an Open Policy Agent server and so on, but in Gloo Gateway you don't need to do that. We have these Open Policy Agent libraries directly in our X.dot server. So if I go to Gloo system here, I can see we have this X.dot server. This is the one that implements this OIDC workflow we have just configured, and it also has this OPA library. So we can just pass some Rego code through a config map here. So I say this is a Rego rule that says that I want to check if the JWT has a claim email that ends with solo.io. So I only want to allow users from the solo.io organization to access my application. As you have seen, we already have this X email header here, so we could also create the Rego rule just to use this header instead. But I wanted to show you that you can do that with claims, so you can access any claim and use that in your authorizations. You could also say, based on this claim, I want to allow only accessing this specific path and so on. So I create this config map and I update my auth config object to have a second step. After I do authenticate the user, I want to authorize the request with OPA. So just click on that. Now, if I try to access my application again, I am rejected. So I need to log out with the path we defined before. And now I'm going to authenticate with another user called user2. And you can see this one has access to the application because you can see the email is ending with solo.io. So everything is working well. So that's really just like a basic authentication. We could use also other options there. We could use API keys and many other options. But then what I want to do now is to show you that you can create a more complex workflow by building upon this authentication and authorization. So let's first modify the root options to add a new rule to transform the request. And you see here, I will apply this stage transformation in regular. We have regular and early. Why? Because you can decide where you want to apply the transformation. Early would apply here before we authenticate the user, and regular will be here after we authenticate the user. Obviously, we want now to transform the header that is called X email, and we get this header added after authentication. So we need to use the regular stage. And what we do is something very simple. We use a regular expression to extract from the X email header only the domain portion of it. So in this example would be solo.io, and we create a new header called X organization that has this value. So if I apply this change here in the root option and I go there and I refresh, you can see I now have this X organization equals solo. Why would I do that? Maybe not just to allow the application to know what is the organization of the user, but because I can now leverage this to apply rate limiting, not at the user level, but at the organization level. So I can create a rate limit config object and say I want to apply a rate limit of 3 requests per minute for any user of this organization called solo.io. And to determine the organization of a user, I need to extract that information from the header name. And again, I just update this root option here so that I basically add this rate limit config object after these other options. So it's going to apply also the rate limit to this path. So I do this, and here I should still be able to access 3 more times, and then I am rate limited, you see, with this 429. You could even like apply a transformation now to transform the response. If I have a response code 429, I want to display this HTML value, for example. So you could do even more than that. So that's like a basic authentication / rate limiting workflow that we see a lot of our customers applying. But you see this case, we use Gloo Gateway and we use the Kubernetes Gateway API with our extensions to perform these operations. The other thing that you can do, this like OIDC workflow is really good for authenticating users. But when you want to authenticate application, you generally get JWT tokens. So here we are going to just create an upstream to represent our Keycloak endpoint. and we are going to create this virtual host option to define that we want to authenticate any request for the HTTP bin listener with this JWT token. And again, what we want to do is to extract the claim email and create a header X email from it. But what you see here is that we don't use a root option where we apply that at the child level like we did, which means that it was configured by the application team if you wish. Here we consider that we apply that at the gateway level, and that's going to be applied for any route that the um, application team in charge of the HTTP bin application would configure. So that's a different way to do it. So we just like apply this rule here. And now if I try to access the application, you see it tells me that the JWT is missing. I'm going to get a JWT from Keycloak. And here now I can try and I can see I can authenticate myself with this JWT, and I can get the XML. Again, like generally use JWT more for application to application communications, but here I just like give you an example as a user. You can also do the same we did before with this X.dot server. You remember we also tried to authorize the user, right? So here we can authorize the application if you wish. And everything that I show you here with the JWT is not going through this X.dot server. In that case, it's really a filter that we have built directly on Envoy. So if we go back to looking at the different components, here we use this proxy, Gloo proxy HTTP, which is Envoy. And we have this JWT filter that is running directly here. So it doesn't have to go and do an extra hop and communicate with the X.dot server to perform this JWT authentication and authorization. So for authorization, we update the virtual host option so that we have this airbag section, and we say we only want to allow here the user to at solo.io, the user that has this claim email to access the application. And if we try again to access, you see we get this airbag access denied. But if we get a token that represents the other user, then we can now access the application and we can see the email correspond to what we have allowed. So let's delete that and let's end our overview of this secure workflow with WAF. So this one shows how you can protect yourself from the log4shell vulnerability. So for people who don't remember, it was like a vulnerability that was impacting Java applications, all the ones that were using this log4j library, which is very common. And the idea here is until all the applications, all the Java applications are updated to use a library version that is preventing this attack, you can very quickly protect yourself at the gateway level by using a WAF rule. So here, what we do is that we apply a root option with a WAF rule that basically can accept any mod security rule. And this is again something that is enforced at the Envoy level with a custom filter we have built based on mod security. And you see here, we show you yet another way to do it. Instead of applying that to the chilled HTTP route, we apply that to the parent one. So you see we did deploy this route option in Gloo system, and here we don't target the HTTP route that is in the HTTP bin namespace, but the one that is in the same namespace here. So it's going to again make sure that this WAF rule is enforced for any request to the HTTP bin application, despite all the rules that can be created by the application in charge of the HTTP bin application. So we just create this rule, and now if I try to take advantage of this vulnerability, I see that this is rejected. So that ends our overview. I think you have seen like how powerful these different policies are, and it's only like a few examples. We can do much more than that.